In this video, we're going to look at mathematical symbols and notations. If you can see here, we've got a list of a few common ones here. So all of these symbols over here on the left are going to represent a common mathematical phrase. So let's take a look and see what some of those are. For example, this symbol here means that it is an element of or belongs to something. So for example here, if I say I have some number A is an element of or belongs to set A, right? We already learned what a set is and that we're going to denote what a set is. We're going to name it using a capital letter. The next symbol, the backwards E, means there exists. Upside down A means for all or for every. And we have the colon or just the straight bar here is going to mean such that. And then the arrow here is used in relationship to a function. That means it's an implication or a mapping, right? So if I had an x value and I plugged it into a certain function f, I would get a very specific y value, okay? So the series of symbols we have here reads like this. It's going to say function f is such that, right? So we have the colon here. So I have function f is such that x maps to y. So all that means is if I take a specific x, plug it into f, I get a particular y. All right, in order to practice this, we're going to take a look at a few examples here. All right, so here we have the upside down A, right? We remember that the upside down A represents the phrase there exists. Okay, and this next part here, sometimes people write it out, some people leave it as the mathematical statement. So I'm going to show you both ways in the same one because you can see we have a similar mathematical statement on the other side. Okay, so either way you want to do this is okay. But we say there exists a w greater than 1, and all we've got a comma, and then it says where w squared is greater than w. So you can see here I've written it out two ways. I've just used this common mathematical phrase, w is greater than 1, or we can actually write out what the inequality says in words, and that is greater than as well. Okay, so two ways you can do it. Okay, so that's taking some symbols, turning it into a phrase. Now here's a phrase. Let's turn it into some symbols. First part of that is the phrase there exists. We know that is represented by backwards capital E. Then we're going to have the part a number b. We're going to represent that by just writing a lowercase b, indicating that could be any number that we're naming b. And then we have the phrase belonging to. We know that is represented by kind of the curved looking E symbol right here. And then we have set B, which is just going to be represented by a capital B. So again, this phrase says there exists a number B that belongs to set B. All right, so now I've got a couple of other examples here. I want you to pause the video and try each of these on your own, and then we'll come back and we'll check them together. All right, so now that you've had a chance to work that on your own, let's see if we can rewrite this series of symbols into a mathematical phrase. So here we have the upside down A and a P, right? So the P is going to represent a number P, and then the A represents the phrase there exists. So we have there exists a number P, all right? So we have this right here, which means such that. So I'm going to write such that. And again, I'm just gonna leave this here. You could write it all the way out in words with the less than phrase in between each of those, or you can just say there exists a number P such that 0 is less than P and is less than 1. And then we can say where P squared is less than P. All right, hopefully you got that. All right, the next one, we're going to take this long, complicated, very wordy phrase here, and we're going to set it into a series of notations and symbols. This is also going to go back to our common number system, so we're going to remember what some of those symbols are as well. So we have the first phrase that says the set of natural numbers. So I'm going to have the capital N, okay, with the double bar there, is an element of or belongs to, right, backwards, or the curved E. Then we have the next phrase, the set of integers, okay, and the integers is represented by Z, the double bar on there, and that belongs to the set of rational numbers. And rational numbers, if you remember, was a Q. Kind of put the double bars there on the outside of the Q, and that is an element of. And then the last one is the real numbers, and real numbers is represented by the R with the double bar right there. All right, so again, I took this long phrase and simplified it into this quick series of symbols. All right, so again, the mathematical notations and symbols is just a shorthand way of writing mathematical statements. Keep this around right here, this chart, keep it handy so you can reference it, and it'll make it a lot easier for you. All right, hope this video helps. We'll see you in the next one.